Hi everyone, in this lecture I'm going to show you how you can combine strings and sort function from the algorithm header file to solve a very simple problem of sorting a list of strings. Okay, so the question is very simple. We will be given input a list of strings and we want to sort them. Okay, so I will just include these two header files, hash include algorithm and hash include string. Okay, so first of all we will take input the value of n, the number of strings user wants to enter. Then I create an array of strings. Okay, so instead of creating an array you can also create a vector of strings, but this time we are going with the array. Okay, so after that we can do scene.get to consume any extra enter that is after \n, and after that we can put a loop to accept n number of strings. Okay, so I can say get line scene comma s of I. Okay, so I'll just define this above. Okay, so this is how we can take input array of strings. And for the string class, scene.getLine does not work. Instead you have to make a call to the getLine function with scene as one of the parameter and s of I as another parameter. This is what you need to do here. Okay, so once we have this, we can just check if we have taken input correctly. We can just output all the strings cout s of I and maybe give a handle here, and let me say okay, I have three fruits, let's say apple juice, mango juice and banana shake. Okay, suppose I want to sort them lexicographically, so let's see. Okay, so this is the output, and as of now we are not doing any sorting. Now what we will do, we will do some sorting, and we can say okay, sort this array of strings starting from s till s plus n. So n is the number of strings. So this is, these are the parameters required for the sort function. And now you might ask how the comparison is going to work. Okay, so by default when you compare two strings, let's say you compare apple with mango, the comparison is based upon the lexicographical ordering. So if I say okay, apple is less than mango, then it's going to return true, and this is going to happen internally inside the sort function because it's going to compare two objects. So this is my first object, second object and the third object. So if I do a lexicographically sorting, I will get apple followed by banana and followed by mango. So let's see what output do we get here in this case. So you can see okay, oh okay, this sorting should be done after taking input. Okay, my mistake. So let's run the code now and see. Okay, so we are getting apple followed by banana followed by mango, but it is also possible that you want to do some other kind of comparison. Maybe you want to compare on the basis of length of the string. In that case we can write our own compare function. So we can say bool compare, and it's going to accept two strings a and b, and the way we are going to compare is not based upon lexicographical comparison that is currently like this. We can say okay, instead of comparing strings, let's only compare the lengths. Okay, so if I say okay, return a dot length is less than b dot length, in that case we will get the same order. Okay, we will get this particular order and same as input, because apple juice is smaller than mango juice and this is smaller than, okay, apple and mango have may have the same length. So in that case we may write another if condition. If a dot length is same as b dot length, if the two strings have the same length, maybe you compare on the basis of lexicographical comparison. Otherwise, you say, okay, return the string that has a larger length. So can you guess what is the output in this case? So we are saying if the two strings have the same length, then the one which is lexicographically smaller will come first, and otherwise one having bigger length will come first. This is what we are saying in this case. And we also need to pass the compare to the sort method. Okay, so using comparators you can define some complex comparisons, and you can do sorting very easily. Okay, so now you have banana shake in the first because it is the string that has the largest length, and apple juice and mango juice have the same length, but since apple is lexicographically smaller, it comes second and this comes third. Okay, so with the help of comparators you can define any sorting criteria. Okay, and here we have used the overloaded less than operator. Okay, and this is going to compare two strings based on the lexicographical ordering. Okay, so this is how we can actually use the string STL to solve one problem, and I hope you would be able to do it now.